Temperatures are increasing because of climate change. It's clear that we could prevent increases in global mean temperature by deploying stratospheric aerosol injection, but the intervention would have its own unique impacts and risks.
In our research, we study the impacts of collective actor scenarios, where stratospheric aerosol injection is used by the global community to maintain or reduce global mean temperatures.
In these simulations of hypothetical collective actor scenarios, the location where aerosol is injected are carefully selected to affect certain aspects of climate, and our research shows that many adverse impacts of climate change may be reduced.
These include high-impact climate variables such as temperature and precipitation across the globe and many regions, and sea ice at the poles.
Even so, there is still much to learn about the impacts of SAI on other parts of the Earth's system. Permafrost, or permanently frozen ground, locks a large amount of carbon safely away in the soil where it can't affect the climate. As permafrost thaws, this carbon could be rapidly released into the atmosphere and further increase temperatures.
We have found that SAI may slow or prevent permafrost thaw. But there is still uncertainty about these impacts, since permafrost depends on processes deep within the soil that are difficult for our computer models to simulate.
There are even more parts of the Earth system where we know even less about the effects of stratospheric aerosol injection. It may also be challenging to isolate the impacts from variability and changes in climate driven by other factors.
This is why it is important to continue to study the impacts of climate intervention, particularly from an interdisciplinary perspective that can help us anticipate unforeseen consequences.